Bismillahirrahmanirrahim. Assalamu alaikum. Today we're going to solve Physics P4 for Cambridge O level. For the session of May June 2023, we have the subject code 5054 and the variant is 42. We have 1 hour for this paper to solve and 40 marks is of paper, and we have total 4 questions to solve it. This is an easy paper. First, a student measured the capacity of a drink of a cup by 3 different methods. The capacity of is the maximum volume of the liquid that it can hold. Method 1. The student measured the height of the cup, the diameter of the D of the cup, the diameter D of the bottom. Shows a full size diagram of the cup. Okay, we can see that we have been given the full diagram of the cup. We need to measure the height, that is h, then diameter D, that is this, and diameter capital D of the cup. Okay, we need to use the scale for it. First we're gonna calculate h, small h, and the height of the cup is 8.3 centimeters. So we're gonna write over here 8.3 centimeters. Now capital D, diameter of the upper side, it would be 6.9 centimeter. So we're gonna write over here 6.9 centimeter. Now we need to measure the small d, that is of the value of 4.6 centimeter. So 4.6 centimeter is small d. We're going to write over here in the answer portion, capital small h is equal to 8.3 centimeter, capital D is 6.9 centimeter, and the small d is 4.6 centimeter. Now we will move to the question part 1. First part. Second part of this question. Okay, calculate the average diameter dA of the cup using your readings from A, and the equation is dA is equal to, so capital D was over 6.9 and small d was 4.6. we have to divide them, and the answer is 5.75. so we're gonna write over here 5.75. That was so easy question. In physics ATP, you can just you have to just put the values and you can score easily. V1 is equal to pi dE square pi dE square h over 4. So we need to put the value pi. Diameter we just calculated 5.75, whole square h we calculated in first part 8.3 divided by 4. Substituting those values in the calculator, our answer would be 215. Examiner has written the answer range for this question is 210 to 220 centimeter. So we move to the next part, that is method 2. The student used a length of string and a meter rule to determine the average circumference C of the cup. The student wraps some of the string 5 times around the cup. Measure the length L of the string used. L is 87.9. Calculate the average circumference of the cup. So we know that it has wrapped 5 times, so circumference, for finding the circumference we will use that C is equal to length over 5 times 87.9 divided by 5. The answer would be 17.58 centimeter. So we're gonna write over here as 17.58 centimeter. Now we move to the second part of it. Use your values of H from A part 1 and C from B part 1 to calculate the value for the capacity V2 of the cup using the equation. V2 is equal to 17.58 square 8.3 over 4 pi. So we will calculate by substituting those values in the calculator, and the answer is 204. Again, examiner has provided a range for the answer, that is 204 till 205. Now we will move to the part C, that is method 3. The student fills a measuring cylinder with water up to 220 centimeter cube mark. Pours water from the measuring cylinder into the cup until the cup is full. Records the new readings R on the measuring cylinder. Figure 1.2 show the new reading R. Write down the new reading of R. So that is 20 and that is 30, 32. The new reading of this would be 32 centimeter cube. Determine the volume water V3 in the cup. Show your working. So we need to find the volume. We know that we have 220 centimeter cube is the original volume, and we recorded the volume is 32. So we're gonna need to subtract those volume. 220 minus 220 minus 32. Here 220 and from this 32. 220 minus 32, the answer would be 188. So our volume from the working number 3 or method number 3 is 188 centimeter cube. Okay, now we move to the D part of the question. All three methods of determining the capacity of the drink cup give the values which are approximate. State one reason why the volume calculated in method 2 and one reason why the volume calculated in the method 3 are not accurate. So there are a number of reasons which you can say that for method 2 would be inaccurate, like the string is not correctly closely positioned, or you can say the string is too tightly packed, string may stretch, string has certain thickness, or circumference of the cup is not uniform, like that it is the shape of like this, yani cup is slowly decreasing, is starting from that and decreasing. So it means that we can write anything from these points. So I'm going to write that circumference of the cup is not uniform, or you can easily write that about the string cup is not uniform. For method 3, cup might have been underfilled or overfilled, or water is spilled, water left in the cup. So you could write number of reasons. I'm gonna write cup might have been underfilled or overfilled. So that's how we completed question number 1. Now we will move to the question number 2, that is of electricity portion and application of electricity. A student investigate the effectiveness of the resistance of the current resistance of different combination of resistors and lamp in circuit. The student set up the diagram. The student, like we can say power supply A, resistance and the voltage. The student closed the switch. Okay, measure the potential difference V1 across the resistor and I1 in the circuit. Open the switch. The readings on the voltmeter and ammeter are shown in the figure. We have been provided with the figures. I'm gonna show it. So voltmeter is showing this reading, that is equal to 2.9, and ammeter is showing the readings 0.4, 1, 2, 3, 4 and 6, 0.46. So this is the reading of ammeter and this is the reading of voltmeter. Okay, now we're gonna read the requirement for this part is record the potential difference and the current I1 in the shown in the figure. We have already mentioned that is equal to 2.9, and we calculated the current, that is equal to 0.46 ampere. Calculate the effective resistance R1 of the combination of resistor using the equation. Okay, we have been provided with the equation as well. V1 value is 2.9 and for the current value 0.46. After dividing this, the answer would be 6.3 ohm. So we're gonna write over here 6.3 ohm. Suggest why switch is open after reading of the potential difference and current have been taken. After reading the current, we open the switch so that it would not overflow, or we do not waste our energy resources, as we need to conserve them. So for saving the energy, you can write, or to prevent resistor to become too hot, to allow resistor to cool down. So you're gonna write as many points as you want, but you need to write only one point to save power, or you can also mention that to prevent it from overheating. So any 2 points, any 1 point is actually required. So you can write over here. Now we will move to the next part, that is B part. The student rearranged the circuit so that the resistors are connected as shown in the figure 2.4. Close the switch. Measure the potential difference V2 and the current I2. Then open the switch. Okay. The new readings are V2 is equal to 2.8 volt, I2 is equal to 0.88 ampere. Calculate the effective resistance R2 of the combination of the resistor using the equation. R2 is equal to V2 over I2. Record your answer on the answer line. Write down the value of R2. So this is an easy question. For R2 we have been given the values, that is V2 2.8 and I2 the value is 0.88. After dividing those two values, the answer is 3.18, or we can round it to 3.2. So write down the value of 2R2 by multiplying 2 with 3.2. The answer is 6.4. So we're gonna write over here, for R2 the value is 3.2, for 2R2 the value is 6.4 ohm. Okay, now we move to the second C part of the question, that is if the resistors are identical. Theory suggests that R1 is equal to 2R2. Two quantities can be considered to be equal within the limit of experimental accuracy if their values are within 10% of each other. Okay, it means that we have a margin of 10% of error. State whether the result indicate that resistors are identical. Support your statement with the calculation. Okay, so we have already calculated R1, that was 6.3 Then we have calculated 2R2, that was 6.2. 6.2, or I think 2R2 was 6.4. So we're gonna rewrite over as 6.4. Okay. R1 is 6.3 and R2 is that, yes. By taking the 10% of 6.3, how are we gonna take it? 10 by 100 over 0.6 multiply by 6.3. The answer would be 0.63. Okay, for it means we need to add 6.3 plus 0.63, then we need to subtract 6.3 minus 0.63. So after adding, the value would be 6.93, and after subtracting, the value is 5.67. Why we are subtracting 10%? Because we have given the safety margin, that is of 10%, and so highest value 6.93 and 5.67. The answer is within the range of 5.67 and 6.93. So we're gonna write over here, they have the same value. It is with the, or we can say they have the same value. They have the same value, or you can write it is within the limit of 10% experimental accuracy. So within the 10% accuracy, we have the answer 6.4. That's why this is acceptable. The student repeat the experiment in A, part A and B, but replaces the resistor with lamps. The effective resistance R3 of the combination of the lamp connected as in the figure 2.1 is 5.2 ohm, and the effective resistance R4 of the combination of lamp connected in 2.4 figure is 3.4 ohm. Okay. The teacher explained that the resistance of the lamp filament changes due to the heating effect, and therefore R3 is not equal to 2R4. Suggest one observation that student make while doing the experiment that supports the teacher's explanation. Okay, brightness would be different from brightness would be different in both the circuit, and lamp is due to the lamp got hot. Okay, so we're gonna write any one observation from it. So lamps get heat, or we're gonna say that brightness of lamp becomes different. You need to write only one point from these point, or you can also tell them lamp glow, lamp gets hot, brightness of lamp changes, light lamp have different brightness. Now we will move to the part E of the question. The part E is the student extends the investigation using a different combination of 3 lamps to the 2 combination already used in part A and part B. Complete the circuit diagram in the figure 2.5 to show a third way of connecting 3 lamps between X and Y. So we're gonna need to draw 3 lamps between X and Y. We have been given X and Y. We have to here we can plot a lamp, here we can also, so three lengths are connected in series. I'm gonna show them like that, or you can also draw the two lamps in parallel and one third lamp in the series, so the diagram would also be fine, or you can simply put three lamps in a series circuit. Question number 3 is from the lenses topic of light. A student investigate the images formed by a converging lens. The student arranges the operators like triangular object, lamp to power supply, height is, and the converging lens, wide screen, and use the distance from triangular object to the lens. The illuminated triangular object is shown full in the size in the figure 3.2. Okay. Measure and record the height h of the triangular object. So we need to use the scale. The height of the object would be, I'm gonna place over 0 over here, 2.5, 2.6 centimeter. 2.6 centimeter, we're gonna write over here 2.6 centimeter. Okay. The student switch on the lamp. B part. The student switch on the lamp and places the lens at distance u is equal to 20 centimeter from the triangular object. Adjust the position on the screen until a sharp focus image of the triangular object is formed on the screen. The image is shown in the figure 3.3. Okay, 3.3. You can also calculate the h for this. That is equal to 7.75, or you could, or 7.8 exact. H is equal to 7.8 centimeter. Okay. H is equal to 7.8 centimeter. After measuring, I'm gonna write over here answer 7.8 centimeter, or you could write 7.7. It was almost in between those two marks. Calculate the value of 1 over h. Give your answer to two significant figure 1 over h. 1 over h means 1 over 7.8. 1 over 7.8 would become 0.13 per centimeter. So you're gonna write over here cm minus 1, as we have taken the reciprocal of 1 over h. So the answer is 0.13 cm minus 1. The students repeat part B for the different values of u. He records all his reading in table 3.1. U is equal to 20, 25, 30, 40 and 50. H is equal to this 3.9, 2.6, 1.6, 1.1. 1 over h is equal to, we need to find this. So we're gonna write over here the unit of h is centimeter. 1 over h is cm minus 1. .8 centimeter. 1 over h, the value would be 1 over 7.8, that is 0.13. 1 over 3.9, the answer would be 0.26. 1 over 0.38. 1 over 1.6, the answer is 0.63. 1 over 1.1, that answer is 0.91. The next part is complete. The next part is complete the headers by adding the appropriate unit. Calculate the remaining value of 1 over h and add them to the table 3.1. We have already done that. Okay, the part D is, the screen is a square sheet of white card of side 10 centimeter. look at the data in the table 3.1 and suggest why the student does not use the value of u which are less than 20 centimeter, because that image will be too big to fit. So that's why the value less than 20 is not taken. So I'm going to write image, you could see over here, image too big to fit. Or you can also write, but you need to write only one point, image become virtual, cannot be obtained on the screen. So you need to write only one point. On the grid provided, plot a graph of 1 over h on the y-axis against u on the x-axis. Start both axes from the origin 0 0. Draw the straight line of the best fit. Okay, we need to draw the straight line of best fit. So we need to plot between this and this. U would be taken on the x-axis and 1 over h would be taken on the y-axis. So we're gonna write over here 1 over h is equal to 1 over h on y-axis and u is on gonna x-axis. Okay, because the boxes were not clear, so I have written some values already by lead pencil, but now I would perform how I plotted 5, 10, 15. I have choose the scale difference between 5 centimeter, 35, 40, 45, 30, 45, 50 and 55. On y-axis 0.1, this point is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1.0. Okay, first we need to plot that 20 centimeter on the x-axis and 0.13 on the y-axis. Then 20 is this and 0.13 is this. Okay, after this 25 and 0.26, 25 and 0.26. After that 30 and 0.38, 30 and 0.38. Okay, now next is 40 and 0.63, 40 and 0.63, and the last point is 50 and 0.9. okay, I'm 50 and 0.9. so over here 50 and 0.9. so we need to draw the straight line that is best fit as the question required. So I'm going to plot the best fit line. Okay, this is like that. So now we need to calculate the gradient m of your line. Show all the workings and indicate on the graph values. So we need to take the 2 points of it for plotting gradient, or we can take these 2 points which we are already plotted. That would be easier for us to solve and it would help. Okay, you can see that these 2 points are 20, these 2 points are one we will take here 50 and 0.91, and over here 20 and 0.13. so we need to find the gradient. How we gonna find y2 minus y1 over x2 minus x1? So y2 is 0.91 and x1 is 0.13, x2 is 50 and x1 is 20. So the answer is 0.78 divided by 30. The answer would be 0.026. So we're gonna write over 0.02. So if your answer comes 0.27, 0.027, 0.028, 0.029, 0.030, examiner would award you full 2 marks. Okay, so you don't need to worry if your answer deviate from these answer. Okay. Now for the second part is calculate the focal length of the lens. Use your value from A. The equation f is equal to 1 over mh. So we have calculated 1 over 0.026. H in first part was 2.6. So the answer would be 14.2 centimeter. 14.2 centimeter. What measuring the height of the lamp, height of the image on the screen? The student's hand and the rulers obstruct the light from the object and prevent it from reaching the screen. Suggest one improvement to apparatus used by the student to overcome this problem. This is simple explanation. To overcome this problem, student can use translucent screen and measure the height of the image from the back of the screen. So you need to write only 1 point. So I am going to tell you that use translucent screen and measure the height of image from the back of screen. So now we move to the next question, that is question number 4. Question number 4 is plan investigation question. This is our last question. A student investigate the time taken for the ice cube to melt. When they are placed in a beaker of hot water, plan an experiment. Investigate how the thickness of the cardboard insulation around the beaker affect the time taken for the ice cube in the beaker to melt. The following apparatus is available. That is 250 centimeter cube of beaker, supply of hot water, supply of ice cube, thermometer, stopwatch, supply of 2 millimeter thick cardboard sheets. In your plan, you should, these are very these instructions you should read it very carefully. Explain briefly how to carry out the investigation. Okay, state the variables to be kept constant. Draw a table with the column heading to show you how to display the readings. We need to draw the table. Explain how to use readings to reach a conclusion. So first we need to draw a label diagram for it. How we're gonna construct this? We are provided with a 250 centimeter cube of beaker. So the beaker has, so we will plot a beaker. You can use scale. Oh, as everyone is know how good I am in the drawing, so I'm not using the scale. So this is thermometer, and we need to show that is dipped inside the hot water. Now we need to draw another beaker. This beaker has also hot water, but now we have covered with an insulation sheet that is wrapped around it. Yeah, it is protected by insulation sheet. We also need to draw the ice cubes. So I'm gonna write hot water and ice cube. Okay. First we need to measure the time taken to how much is time required to my mobile was full, so the video was paused. Welcome back, and we're gonna write over here the answer. So first we need to measure the time taken to melt how much time is required to melt the stone. Time is measured at how much time is required to melt the ice, and we will use stopwatch with the help of stopwatch. Okay. Now repeat with at least 4 more layers. Repeat the same experiment. Repeat it with at least 4 more layers. Key variable are, first we need to record initial temperature of hot water, mass and volume of cube, same mass and volume of water. Need to record the room temperature. It could be also varied room temperature. temperature of ice cube. So after writing it, we need to draw the table for it. And for table, there are two important things we need to show over here. Number of layers of isolation, not insulation, and time to melt ice cubes. 1, 2, 3, 4. So this is how we're gonna make our table. Okay, you also can show by plotting a graph as well. For y-axis, you need to take number of layers, and for x-axis, you need to take number of layers of insulation, and for y-axis, you need to take time taken to melt the ice. Okay, so if there will be more insulation layer, obviously it would require more time, and if had less insulation layer, less time would be required. So it would be linear relation. Plot of the graph of thickness against the time, or plot a graph against the time plot a graph of thickness of insulation. Again, now by comparing result, we will be able to comparing result would enable us to give conclusion. See, so we're gonna write that how thickness able to change it with the passage of time, and if thickness and insulation has more thickness, it means that it will require more time. Hopefully you would have a great understanding of this paper, and paper was easy, and there were few points which to be noted. You need to calculate those points, and you need to mark those values with much care. Recalculate your value if you have some doubt, and do watch the video and share with your friend. Your upcoming exam for the physics P4 is very near. I hope you would find this video very helpful. So thank you so much, and Allah Hafiz.